In this problem here, we are going to have to do a little bit of quadratic regression. And since we've never seen that before, possibly, I wanted to show you how that works. And so for this problem, this is question number 15 out of section 10.2. We're going to plot the data. And so what they suggest that we do first here, and this is a smart move, is let's first start by creating a table of values. And if you see part A, all they want you to do here is write down 1940 as 40. 1950 is 50, and you keep adding 10, and so when you get to 2000 you call that 100 and 110. The reason you want to do that is just because when you plot these values it makes more sense. Rather than have the x-axis go out to 1940, just have it go out to 40. So we're going to choose the correct graph, and they show how to use the window size. So I'm going to show you that on the graphing calculator. So once you're on the graphing calculator, press Stat here and edit, and that allows us to put in our data values. So I'm going to type in the data values for 40, 50, 60, and then I'm going to come back and type the rest of them. So as you can see here, I put in the data, and now we're going to graph it. So we're going to press Y, and what we want to do is actually not Y, but see above Y it says Stat Plot. We'll do second Y, and we'll turn plots 1 on. So we press Enter and turn it on. And then our X's will come from list 1 and our Y's will come from list 2. And so we have everything we need here to create this graph. So we click Graph. And now you notice we can't see anything. So they say change the viewing window. So here's how you change the viewing window. Click Window. And so our X min will be 30. Our Y or X max will be 120. And our scale will be 10. And then 18 is our minimum for Y. 30 is our max, and our scale is 2. That's what they mean by 30, 20, 10, and 18, 30, and then 2. So now let's press Graph, and now we create the graph that we're looking for. So you can see that choice A right here is going to be the correct answer. And so for part B, we have to pick from these drop-down boxes, and this explains why we use quadratic here. If the points on the graph look like they're close to a straight line, then a linear model would be better. Otherwise, a quadratic model would be better. Based on the graph of the data here in A, the points look like they are close to a simple curve. Therefore, a quadratic model will best fit the data. So those are just the boxes that you pick there. And now part C says, use the regression feature of a graphing calculator to find the quadratic function that best fits the data. So we have done this before as linear regression. Perhaps, and so what we're going to do is pull the calculator up and do a quadratic regression. So we have our calculator here. I'm going to clear out the graph just to get a clear screen. So we're going to press Stat and move over to Calc. And as you go down the list, the one that's most common that perhaps we've done before or you've done before is linear regression, where you get a linear fit. So option 5 is called quadratic regression. So we choose that and press Enter, and we're going to say second L1 comma second and then L2. Alright, then we press Enter, and we get our function here with A, B, and C. So a quadratic follows this formula of ax squared plus bx plus c. So we need to type in an expression as f of t. So they use x, we need to use t. So let me get a screen snip of this calculator output, and then we'll type it in. So as we write this function out, what we have to do is use t. Now notice our problem wanted to use x, but we've used t, so we'll write f of t is, and a is 0.0027, right? So we round it to 4 decimal places. That was the instructions here. And since the variable we're using here is t, we write t squared. All right, and then our next one is a negative, and so we'll write minus 0.323, and that rounds up to a 5, and then we'll put t. And then our final is c, and it's positive, so we write plus 30.4857. All right, and that will be the function that you write here in this box. And so our final step here is to choose the correct graph. So we're going to go graph this. So I'll press Y, and we'll type in this function 0.0027, and we're going to have to use x back over here because the calculator does operate on x, minus 0.3235x plus 30.4857. And so now we'll graph, and you can see that it creates a graph that almost goes through all the points, and that's what quadratic regression does. It tries to find the best quadratic function that will go through all the points or get as close to them as possible. And so we would choose answer choice A right here. And then we have part D here, where we want to do a quadratic function using what we call the vertex form. All right, so the vertex form, if you haven't seen it in action before, when they tell you the vertex is 60 and 20.6, 60 represents this letter right here, H, in the vertex form, and 20.6 represents this number K. So when you see a vertex, we typically express it as H comma K. All right, so H is the 60 and 20.6 is the K. And then we're going to choose a second point, 110 and 27.2, to determine the value of A. So let me show you how you do this algebra. This is a little small bit of algebra here. So if 110 right here represents T, and then 27.2 here represents F of T. All right, so for F of T, I'm going to put 27.2. So I'm going to rewrite this equation, by the way. Here's what I'm doing. F of T is 27.2 equals A times, and T is 110 minus, and our H is 60. And we're going to square that, and then we say plus K, and our K is 20.6. So now we have to do the algebra here to solve for A. So the first thing I'll do is subtract 20.6 from both sides. All right, so on this side we get 6.6 equals A times, and then 110 minus 60 squared. 110 minus 60 is 50, and we're going to square that. So we get, kind of running out of space here, I'll come back over here, 6.6 equals, and 50 squared is 2,500, and that's times A. So now we divide both sides by 2,500 to get our coefficient of A. And so we get our calculator out. And so let me clear off my graph. And so I'm going to type 6.6 divided by 2,500. And of course, any of that other math you need to, I did that in my head, but if you need to use the calculator, of course, use it. So we get A is 0.00264. All right. 0.00264. All right, so let's see exactly what we need to type in here. So to write the quadratic function, set H equals 2, and that's what we said, that in the box right there is 60. K will be 20.6. T will be 110. And F of T will be equal to 27.2. That's what goes in those boxes. They're just making sure we know what goes in what box. All right, so just to clean that up a little bit, my handwriting wasn't that good. I typed in the H is 60, K is 20.6, T was 110, and F of T was 27.2. And now we got to write that function. So keep in mind, sometimes students get a little confused on this. This 110 is 27.2. We need that to find A, but once we have found A, we no longer need that. So remember, our A was 0.00264. We round that to 2 decimal places, and that's how we get 0.0026. And so we continue to use the vertex of T minus H, which was 60 squared, plus K, which was 20.6, and that's how we get our function. And so then our final step is to graph that function from part D on the same calculator window as the data in the function from part C. And as you can guess, if we do that, this graph is continued to look the same. It's this one that kind of is a low sloping line, but you can do that as well. So if we come back over here to our graph, we'll say y equals, and now you just go down to y2, and you can put in this new function 0.0026 parentheses x. Again, remember we use x in the calculator. Close parentheses squared plus 20.6. And now we'll graph both lines, and you can see they're almost laying on top of each other. They are distinct lines, and down here, I guess if you zoomed in on part D, you could see that there's 2 different lines, and you can kind of see a little bit of daylight there. But of course, this graph D is the correct picture. So anyway, I hope this helps, and let me know if you have questions.